Welcome to MyProjectBazaar.com.
Now we discuss about Flying-Capacitor-based hybrid LLC converters with input voltage auto balance ability for high voltage applications. There are many types of converters will be used in DC to DC process. In our proposed, we design a type of DC to DC buck converter for use in the high voltage application for reduce the high voltage to low voltage DC output. In our proposed, using the flying capacitor based LLC converter. The flying capacitor is one type of the inverter technique. Here we use the half bridge and auto balance. Here we use two different type of half bridge. One half bridge will be used in the primary side of the transformer and another half bridge will be used in the secondary side of the transformer. And both half bridge will be able to balance the output power and input power. So that reason it will be help to reduce the switching loss and the harmonic of the DC output, and it will be easy to reduce the high voltage to low voltage DC from two half-bridge balanced. Here the flying capacitor will be used to bypass the harmonics or unwanted AC lines into the ground. So that reason it will be help to reduce the amount of switching and also the charging and discharging rate. It will be rectify the switching loss in the switches. For that reason, it will be the best design for the high voltage application for both the DC to DC converter. In our proposed, we design this thing in the MATLAB Simulink environment and output the and find the or verify the output for it will be give the correct output or not. It is the flow diagram for our proposed work. In this flow diagram, we use the source. The source is the DC input. Here we use the 600 volt DC. Because our proposed work will be the high voltage DC to low voltage DC for the buck converter. The DC source given to the input of the inverter. The inverter will be controlled by the pulse width modulation, and that inverter convert the high voltage DC to high voltage AC output. The high voltage AC from the getting from the inverter, it will be sent through the transformers. The transformers, the step-down transformer will be used. The step-down transformer step down the high voltage AC to the low voltage AC, and that low voltage AC goes from the another converter. Here, the inverter is the one of the half bridge and the converter is the another half bridge. So that is, it will be like a full bridge and it will be auto balance the converter and the converter for reduce the harmonics in the DC output. And the AC transfer output sent to the converter convert the low voltage AC to the low voltage DC, and that low voltage DC will be go to the load. And we control the both inverter and converter by using the PWM. In enhancement, we use any controller for use this here to maintain the PWM for maintain the higher output efficiency. Now we go to see of our Simulink model for the flying capacitor of LLC DC to DC converter. In our model, first we generate the source from the DC to DC converter. Here we use the normal DC source and with amplitude of 600 volt, and that will be connected to the two capacitor for maintain the power, because in the high voltage the output will be getting from the 3-base AC source and it will be converted to the high voltage DC. So that reason the DC gets some unwanted harmonics here. For that reason we use the two capacitor for reduce the harmonic in circuit, and that is connected to the resistor, because the capacitor will be connected to the parallel of the DC source. It is not able to convert the current. So that reason we use a resistor for convert the capacitor to the series connections. And now that are two half bridges will be interconnected in the primary, one within the series connected cells, and both will be getting the each separate capacitor. It is a flying capacitor, and it is used to charging and discharging the DC or AC current during the positive and negative off cycles. Here the inductor will be connected, that is the base inverter will be connected. The two will be the inductor and another is the primary side of the transformer, and that hybrid will be each hybrid converted the one hybrid circuit will be converted the DC to positive negative cycle of the AC, and another will be converted to the DC to negative cycle of the AC source. And the flying capacitor will be able to control the neutral position for the capacitor. So that reason here we take the three type of conditions will be getting. One will be the positive, and another will be the zero, and another will be the negative cycle. In another converters there are two types of coils will be there. One is the negative or another one is the positive cycle. Here we use the playing capacitor based on two hybrids. It will be balanced. So that reason here we know that zeros will be coming in the AC conversion, and that AC will be sending through the transformer with two different types of output. Three winding. The primary side one winding will be conducted, and the secondary winding there are two different windings will be two windings will be used, and each winding will be generate the different types of outputs, and both will be interconnected. For that reason we get the adding of the output, and after the secondary side we use the converter by using the rectifier circuit. The rectifier will help to able convert the AC to DC, because the AC will be the rectifier characteristic will be reduce the negative current or block the negative current. For that reason that AC will be able to help here convert to the DC by using the normal diodes. The diodes will be withstand the high minimum voltage of the breaking point, and it will be connected to the capacitor, because some unwanted DC AC formation will be coming from the after the rectifier. The capacitor will be filtered and it will be ground the circuit. So that we get the pure DC form during the buck-to-buck conversion, and at the final it will be connected to the resistors, and the resistors will help to find the output values. And then we use the normal PWM generators for control the primary side switches. Here we use the MOSFET switches for change the DC to AC output, and we measure the output voltage and output current, and also the input voltage and input current, and these both output and output we find out the power of the input and output, and finally we get the output efficiency. In our purpose we use the 600 volt AC, and we get the output from the 50 volt AC, 50 volt DC, but the power will be changing because the current will be varied based on the power. Thank you.